Out in the desert beyond Cairo stands a structure that, by any honest assessment, seems almost impossible. Not impossible in a poetic or symbolic sense, but impossible as a challenge of physics, mathematics, and even time itself. The Great Pyramid is made up of roughly 2.3 million stone blocks, each weighing anywhere from 2 to 15 tons. Together, they form a monument that once rose 481 feet into the sky. Yet what makes it even more extraordinary is the way those blocks fit together. In some areas, the joints are so tight that even a sheet of paper cannot be slipped between them. For nearly 4 millennia, it remained the tallest structure ever created by human hands. Nothing else on Earth came remotely close. And the more carefully you study it, the more difficult it becomes to explain how such a thing was accomplished at all. In 2024, an artificial intelligence system was presented with what seemed like a straightforward question: who built the pyramids? Not the polite answer. Not the familiar explanation repeated in textbooks and documentaries. Instead, the system was given something no individual researcher has ever truly possessed in one place. It received every available measurement, survey, geological scan, astronomical alignment, and engineering specification ever recorded about the Great Pyramid of Khufu. All of that information was provided simultaneously, along with a single instruction: analyze the evidence without loyalty to any existing theory. Report only what the data reveals. The response that emerged was not what anyone expected. It was not a person's name. It was not a date. What it produced was something far stranger, quieter, and in many ways far more unsettling than any simple answer could have been. Step by step, layer by layer, the machine began dismantling the explanation most of us have accepted since childhood. Take a moment to consider that before we continue. This was not a fringe researcher promoting ideas from a personal website. This was a system with no reputation to defend, no academic position to protect, no career concerns, and no fear of criticism from colleagues. It had nothing at stake. It did not care whether the conclusion was comfortable or controversial. And when it examined the most thoroughly studied monument in human history, it did not simply confirm what we already believed. Instead, it encountered something that could not easily be reconciled with the story we have been told. To understand why that matters, we first need to understand the accepted explanation, and we need to treat it fairly. The official account is neither foolish nor fabricated. It is not a fantasy invented by careless historians. It is a serious reconstruction built by dedicated researchers over more than a century of investigation, supported by substantial evidence. Before questioning it, it deserves to be presented clearly. According to the standard narrative, construction began around 2560 BCE during Egypt's 4th dynasty. Pharaoh Khufu commissioned the pyramid as his royal tomb. Over a period of approximately 20 years, tens of thousands of workers carried out the project. Contrary to popular movie depictions, these were not enslaved masses. They were organized teams of skilled laborers. Limestone was quarried directly from the Giza plateau. Higher quality stone was transported along the Nile. Massive blocks were hauled across dampened sand using wooden sledges and then lifted into position through a combination of ramps, ropes, levers, and enormous amounts of coordinated human effort. The tools available to these builders were relatively simple: copper chisels, stone hammers, and wooden mallets. For measurement, they relied on knotted cords, plumb lines, wooden squares, and trenches filled with water to establish level surfaces. And the evidence supporting this picture is genuine. Archaeologists have uncovered entire worker settlements on the Giza plateau. They have found bakeries, breweries, living quarters, animal remains, and evidence of medical treatment. Injured laborers whose broken bones healed properly suggest that these workers were cared for and valued. Administrative records written on papyrus describe the logistics involved in transporting stone. Quarry markings and tool marks remain visible. Deep within the pyramid, hidden blocks still bear red ochre inscriptions identifying work crews with names such as the Friends of Khufu. In other words, the monument is covered with traces of human activity. The people responsible for its construction left evidence of their presence and, in many cases, signs of their pride in the accomplishment. So when people describe the pyramids as a mystery, it is important to recognize that mainstream archaeology offers a serious and coherent explanation supported by physical evidence. This interpretation is not an attempt to conceal anything. It represents the best reconstruction experts have been able to build from the available facts. And for many aspects of the pyramid, particularly the questions of who organized the labor and why the monument was built, the explanation remains remarkably strong. However, there is a problem. And the more closely that problem is examined, the larger it appears. Rather than shrinking under scrutiny, it grows. The closer you look at the stone itself, the more unsettling the issue becomes. The traditional explanation successfully accounts for the workforce. It explains the organization, food supply, logistics, motivation, and the crews whose names remain painted on hidden blocks. What it struggles to explain is something else entirely. It struggles to explain the precision. The accepted story tells us who moved the stones. It does not fully explain how those stones were cut, fitted together, leveled, and aligned with such astonishing accuracy. In several measurable ways, the construction approaches standards that challenge even modern capabilities. Today we have lasers, diamond cutting tools, satellite positioning systems, and more than 4,000 additional years of accumulated knowledge. Yet some aspects of the pyramid's precision continue to raise difficult questions. That was the specific issue the AI system focused on. Not strength. Not manpower. Accuracy. Because manpower is relatively simple. Given enough workers, enough ropes, and enough years, almost any object can be dragged across sand. Accuracy is different. Precision cannot be achieved through effort alone. No amount of brute force can produce tolerances measured in fractions of a millimeter. No amount of physical labor can automatically create alignments more exact than those produced by professional surveyors. Precision reflects knowledge. Precision reveals understanding. And it is within that precision, not the monument size, weight, or labor requirements, that the numbers begin to behave in unexpected ways. When the system began its investigation, it did not start with theories about forgotten civilizations, lost technologies, or ancient visitors from the stars. It ignored the sensational explanations often discussed online. Instead, it began where any careful investigation should begin. With the foundation. With the floor. With the most basic engineering question imaginable. Is the structure level? Is the ground beneath it truly flat? The moment the machine examined that single, seemingly unremarkable measurement, the comfortable version of history began to unravel, slowly, quietly, and almost imperceptibly. Because the base of the Great Pyramid is not merely close to level. It is not simply approximately flat. Across a footprint extending more than 230 meters on each side, a surface large enough to contain several football fields, the entire foundation varies by only slightly more than 2 centimeters. Think about that. Just 2 centimeters of deviation across a distance measuring roughly 2.5 football fields in length. That corresponds to a flatness of approximately 0.009%. And that is where the numbers first begin to demand an explanation. Once you truly grasp what that number represents, what it would actually take to achieve such precision using nothing more than copper tools, water, wood, and human labor, the story begins to change. The foundation stops feeling like a simple historical detail and starts to resemble a deliberate message left behind in stone. Take a moment to consider that figure. The human mind is not naturally equipped to appreciate just how remarkable it is. 2 centimeters across a span of 230 meters. To visualize it, imagine a sheet of glass covering an entire city block. Across that massive surface, the difference between its highest and lowest points is less than the width of 2 fingers. Now imagine that the surface is not a single piece of glass. Imagine it is assembled from millions of individual stone blocks, some weighing as much as a truck. Every one of those blocks has been shaped, positioned, and adjusted by hand. Then remove every modern tool from the equation. No laser levels. No optical surveying equipment. No precision instruments. No computerized measurements. Only water-filled trenches, wooden squares, plumb lines, stretched cords, and human eyesight. The AI system was given a deliberately limited question. Not who built the pyramid. Not why it was built. Only this. Given the tools that the accepted historical record says were available, what are the chances that builders could achieve this degree of flatness across such an enormous distance while maintaining that consistency on every side? The machine did not respond with speculation. It responded with statistics. And the result was not especially favorable to the traditional explanation. The system did not declare the achievement impossible. It was careful not to go that far. Instead, it used a different word. Improbable. Not impossible, just extraordinarily unlikely. The sort of result that should fail far more often than it succeeds. The kind of precision that ought to drift when workers become exhausted. The kind that should be affected by changing temperatures, shifting measurements, expanding cords, or the relentless heat of the desert. What makes the finding even more intriguing is that modern construction rarely requires this level of perfection. Today's engineers generally do not build to such standards because there is no practical reason to do so. When a skyscraper foundation is poured, acceptable tolerances are typically much broader than what is observed beneath the Great Pyramid. A few centimeters of variation across a large structure causes no concern. Buildings remain stable, elevators function normally, and occupants never notice the difference. By the standards modern engineers actually use, the foundation at Giza appears to be roughly 10 times more precise than practical necessity would demand. Think about that. The builders did not merely meet a demanding standard. They exceeded what modern engineering would consider sufficient for a structure that, according to the accepted explanation, was intended as a tomb. Which naturally raises a question. Why? That question emerges directly from the foundation itself, and it follows us throughout the rest of the investigation. Because precision comes at a cost. Every additional fraction of accuracy requires more time, more expertise, more repeated measurements, more discarded material, and more labor invested in a result that appears to offer no obvious practical advantage. A tomb does not require a foundation accurate to 0.009%. The dead are unlikely to care about slight variations in slope. If the precision served no practical function, only two possibilities remain. Either it was an unintended consequence of construction methods so refined that extreme accuracy emerged naturally, or the precision itself was the objective. Either the builders could not avoid being this accurate, or they wanted future observers to notice it. At this stage, the system did not choose between those possibilities. It simply recorded the anomaly and moved forward, much like an experienced investigator noting a detail that does not fit while refusing to ignore it. Then its attention shifted away from the ground. It began examining orientation. Not how level the pyramid was, but how it was positioned upon the landscape. The direction it faced. And that is when a second number emerged. If anything, this one was even more difficult to explain. Because the Great Pyramid is not merely level. It is precisely aimed. Its sides do not face approximately north, south, east, and west. They face true north, true south, true east, and true west. And they do so with an accuracy that remains astonishing even today. The deviation from true north is only about 3 arc minutes. 3. To understand how small that is, consider that a single degree contains 60 arc minutes. The entire horizon surrounding you consists of 360 degrees, or 21,600 arc minutes. Across that immense circle, the builders missed perfect north by only 3 arc minutes. The error is so small that no person could detect it by sight alone. You would need instruments to measure it. And this is where the situation becomes even stranger. True north is not the direction indicated by a compass. Compasses point toward magnetic north, which constantly shifts over time. True north is something entirely different. It is the Earth's rotational axis, the exact point around which the planet spins. There is no physical marker identifying it. No mountain. No stone. No landmark. To find it, one must observe the heavens. You must carefully watch the stars move across the night sky and determine the invisible center around which they rotate. Then you must translate that celestial point into a line on the ground. And after establishing that line, you must preserve its accuracy across more than 230 meters of construction. The AI flagged this immediately. Such accuracy is not typically achieved by accident. Today, comparable precision is associated with professional surveying equipment, satellite measurements, and highly refined instruments developed thousands of years after the pyramid was built. Then the system asked a question that textbooks rarely address directly. Why would anyone need this level of accuracy? A tomb does not require alignment to true north. A royal monument does not require it. Even a temple can function perfectly well without being oriented more precisely than modern surveyors routinely achieve. The alignment is so exact that the people standing beside the structure could never appreciate it with the naked eye. No ceremony depended upon such minute accuracy. No observer could perceive the difference. The precision exceeds the apparent purpose. It goes beyond every practical explanation typically offered. And when accuracy surpasses necessity by such a wide margin, an uncomfortable possibility emerges. Perhaps the accuracy was the purpose. Perhaps the alignment was not simply a means to achieve something else. Perhaps the alignment itself was the statement. Perhaps someone standing on that plateau thousands of years ago invested extraordinary effort into directing this mountain of stone toward the fixed center of the heavens. Perhaps they did so knowing that almost nobody would ever notice. Except, perhaps, those living far in the future who possessed the tools to measure it. The machine asked that question. And the next number it encountered began to suggest an answer. This next clue appeared in the form of a mathematical ratio. Simple enough for a child to calculate, yet strange enough to spark debate among scholars for centuries. Take the perimeter of the pyramid's base. Measure all four sides and add them together. Then compare that value to the pyramid's original height before its casing stones and capstone disappeared. Divide the perimeter by the height. The result is not a neat whole number. Instead, it approximates twice the value of pi. Pi, the endless irrational number beginning with 3.14159 and continuing forever without repetition. The same number that defines the relationship between a circle's circumference and its diameter. Remarkably, the pyramid's perimeter relates to its height in a way that mirrors the relationship between a circle's circumference and radius. A structure built from squares and triangles appears to contain the mathematics of a circle hidden within its proportions. And according to the system's analysis, the correspondence is surprisingly close. Not within 5%. Not even within 1%. But within approximately 0.05%. The traditional explanation acknowledges this observation and offers a reasonable interpretation. According to that view, the relationship emerged unintentionally. Egyptian builders measured horizontal distances using rolling cylinders or wheels while vertical measurements relied on cubits. Under those circumstances, geometric relationships involving pi can appear naturally without anyone consciously calculating them. The circle effectively performs the mathematics on its own. It is a clean explanation. An elegant one. And if this were the only appearance of the ratio, it might be sufficient. But the machine was not examining a single measurement. It was examining the entire structure. Every dimension. Every proportion. Every survey available. And it discovered that the relationship appeared repeatedly. Not in one isolated location. Not as a single coincidence. The same mathematical signature surfaced at multiple independent points throughout the geometry. Relationships that shared no obvious common cause. Relationships that could not all be explained by the same measuring wheel. So the system did what it was designed to do. It calculated probabilities. It asked how likely it was that the same ratio would repeatedly emerge by chance in unrelated parts of the design. The answer was troubling. The probability was low enough that many fields would stop using the word coincidence altogether. A different word becomes more appropriate. Intention. Because coincidence does not repeatedly appear wherever you search for it. Coincidence does not leave the same fingerprint over and over again. When identical patterns emerge in places lacking a common cause, chance becomes increasingly difficult to defend. At that point, you begin looking at decisions rather than accidents. Then the machine uncovered another mathematical fingerprint. One even stranger than the first. Pi was at least known indirectly in the ancient world. This next number was different. It was phi. The golden ratio. Approximately 1:618, continuing endlessly. The proportion often associated with natural patterns, spirals, branching structures, and forms that humans instinctively perceive as aesthetically pleasing. According to conventional history, this ratio was not formally described until Greek mathematicians documented it more than 2,000 years after the Great Pyramid was completed. 2,000 years. A span comparable to the time separating us from the Roman Empire. Yet the machine identified phi throughout the pyramid's design. Not once. Multiple times. It appeared in relationships between height and base dimensions. It appeared in the slope angles of the pyramid's faces. It appeared within aspects of the internal geometry. And unlike pi, these appearances cannot be explained through rolling measuring devices. A wheel can introduce circular relationships. It cannot naturally generate phi. The golden ratio emerges from entirely different mathematics. The system counted at least 7 independent dimensional relationships involving phi. 7 separate locations. 7 separate occurrences. 7 places where a proportion supposedly unknown for another 2 millennia appears embedded within the structure. As if the builders not only understood it but considered it fundamental enough to weave throughout the monument itself. This is where the investigation becomes more difficult to dismiss. One could argue that pi emerged accidentally. The same argument becomes much harder to make for phi. There is no obvious tool, measuring process, or construction technique that secretly introduces the golden ratio by mistake. To use phi consistently, one generally has to understand it. To calculate it. To apply it deliberately. Finding it once might be forgivable as coincidence. Finding it 7 times begins to resemble a signature. Almost as if someone left mathematical handwriting within the stone itself, a language not formally recorded until thousands of years later. The system compared both numbers. Pi and phi. The circle hidden inside the square. The ratio that seemingly appeared before its documented discovery. And it observed a common characteristic. Both are irrational numbers. Both extend infinitely. Both represent deep mathematical relationships associated with advanced understanding. The sort of concepts civilizations typically develop only after long periods of intellectual growth. Yet here they appeared at the very beginning. Within one of humanity's oldest monumental structures. According to conventional history, these builders were using copper tools and wooden sleds. Yet the mathematics embedded in the monument does not appear primitive. It appears fully formed. That observation led the machine toward its next question. Away from the pyramid itself. Toward the planet beneath it. The system took measurements from the pyramid and multiplied them by a specific number. What emerged was unexpected. Using the pyramid's original height, it applied a multiplier of 43,200. The resulting value closely approximated Earth's polar radius. Then it performed the same operation using the perimeter of the base. Again multiplying by 43,200. The result corresponded closely to Earth's equatorial circumference. The same multiplier. Two separate dimensions. Two separate planetary measurements. As though the pyramid functioned as a scale representation of Earth using a ratio of 1 to 43,200. The number itself is intriguing. There are 43,200 seconds in 12 hours. It is connected to the Earth's rotation and the passage of time from day into night. To find that same number linking the dimensions of a monument to those of the planet invites questions. Questions the machine could not easily dismiss. Who, in the 3rd millennium BCE, possessed knowledge of Earth's dimensions? Who understood the difference between polar radius and equatorial circumference? And if such knowledge existed, why encode it within a structure of stone? Why leave it there for future generations to discover? The traditional explanation argues that such relationships are merely numerical coincidences, artifacts created by the qubit system and the tendency of large structures to produce interesting ratios. The machine actively tested that possibility. It searched for innocent explanations. It searched for randomness. Yet the pattern it kept encountering appeared increasingly layered, increasingly consistent, and increasingly deliberate. Extraordinary leveling. Alignment to true north beyond practical necessity. Pi woven into proportions. Phi appearing repeatedly throughout the design. And the investigation was only beginning. It is an elegant explanation. On the surface, it is neat, logical, and for a single occurrence, it works remarkably well. The problem is that the machine was never examining a single occurrence. It wasn't focused on one measurement or one isolated coincidence. It was analyzing the entire monument, every recorded dimension, every surveyed angle, and every measurable relationship hidden within the structure. What it discovered was that this pattern did not appear once and disappear. It appeared repeatedly. The same relationship surfaced in different areas of the pyramid's geometry, emerging in proportions that had no obvious connection to one another. These measurements could not all be explained as the byproduct of a single construction technique or a rolling measuring drum. So the system did what it was designed to do. It calculated probabilities. It asked a straightforward question: what are the chances that the same mathematical relationship would emerge independently, in multiple unrelated parts of the design, purely by accident? The answer it produced was difficult to ignore. The probability was low enough that in many scientific disciplines it would force researchers to stop using the word coincidence altogether. A different word would become necessary. Intention. Because coincidence does not repeatedly appear on demand. Coincidence does not leave the same signature wherever you choose to look. When the same pattern emerges again and again in places that share no obvious cause, chance becomes a weaker explanation. At some point, repeated coincidence begins to look less like randomness and more like deliberate design. Then the machine discovered another pattern. And this one was even more unusual. Pi, at least, was a concept that existed in the ancient world, whether or not the Egyptians formally recorded it. The next number was different. It was phi. The golden ratio. Approximately 1.6180333988 and continuing forever without repetition. It is the proportion often associated with natural beauty. It appears in spiraling shells, branching trees, flower structures, and countless patterns throughout nature. Human beings frequently find it visually pleasing, even when they have no idea why. According to the conventional historical record, however, this ratio was not formally described until Greek mathematicians documented it thousands of years later. More than 2,000 years later. Think about that time span. The gap separating the construction of the Great Pyramid from the formal description of the golden ratio is roughly comparable to the distance between our own era and the Roman Empire. By everything we can currently verify, phi was not a recognized mathematical concept when the pyramid was built. Yet the machine found it there. Not once. Multiple times. It appeared in the relationship between the pyramid's height and base dimensions. It appeared in the angles of the sloping faces. It emerged within aspects of the internal geometry. And unlike pi, these relationships could not be explained by the simple act of rolling a measuring wheel. A wheel can naturally introduce circular mathematics. It cannot naturally generate phi. The golden ratio belongs to an entirely different category of mathematics. The system counted every occurrence it could identify. The total it returned was at least 7. 7 separate dimensional relationships. 7 independent appearances. 7 locations where a mathematical proportion supposedly unknown for another 2 millennia appeared to be embedded within the monument itself. It was as though the builders not only understood the ratio but considered it important enough to weave throughout the structure's design. This is where the investigation becomes genuinely uncomfortable. A determined skeptic might argue that pi entered the design unintentionally through practical measurement techniques. That argument becomes far more difficult when discussing phi. There is no will that secretly generates the golden ratio. No measuring stick that accidentally creates it. No ordinary construction procedure that repeatedly inserts it into dimensions without anyone realizing it. To use phi consistently requires awareness. It requires understanding. It requires deliberate application. Finding it once might be dismissed as coincidence. Finding it 7 times, distributed throughout the pyramid's geometry, is much harder to dismiss. At that point, it begins to resemble a signature. A mathematical signature. Almost as though someone left their handwriting within the stone using a language that would not be formally described for another 2,000 years. The machine considered both discoveries together. Pi. The circle concealed within a square monument. And phi. The proportion that seemingly appeared before it was supposed to exist. It noted a striking similarity between them. Both are irrational numbers. Both continue infinitely. Both represent deep mathematical principles associated with advanced understanding. They are not simple arithmetic tricks. They belong to the kind of knowledge civilizations typically reach only after centuries of intellectual development and careful study. Yet here they appeared in one of humanity's oldest and most iconic monuments. According to the traditional narrative, the builders were working with copper chisels, wooden sledges, and relatively simple tools. But the mathematics embedded in the monument did not appear simple. It appeared sophisticated. It appeared complete. Rather than showing a gradual progression toward advanced knowledge, the structure seemed to begin with it already fully formed. That realization pushed the machine toward its next question. Its attention shifted away from the pyramid itself and toward the planet beneath it. The system took measurements from the monument and compared them against a specific multiplier. The results stopped the analysis in its tracks. Using the pyramid's original height, before the casing stones disappeared and the capstone was lost, it multiplied that measurement by 43,200. The resulting figure closely matched Earth's polar radius. Then it performed the same calculation using the perimeter of the pyramid's base. Again, it multiplied the value by 43,200. This time the result corresponded closely with Earth's equatorial circumference. The same multiplier. 2 different measurements from the pyramid. 2 different measurements of the planet. 1 connecting factor. The relationship made it appear as though the monument functioned as a scale representation of Earth itself, built according to a ratio of 1 to 43,200. As though the dimensions of the planet had been quietly encoded into stone. Consider that number carefully. The machine certainly did. 43,200 is not an arbitrary value. It is the number of seconds contained within 12 hours. It is connected to the rotation of Earth and the cycle of day and night. A number tied directly to planetary motion and time itself. To find that same value linking the dimensions of a monument to the dimensions of Earth is the sort of coincidence that inevitably invites scrutiny. At a certain point, repeated coincidences begin to resemble a deliberate message. The machine, having no investment in wonder and no concern about criticism, framed it exactly that way. As a question. A question it could not easily resolve. Who, in the 3rd millennium BCE, possessed knowledge of Earth's dimensions? Who knew the planet's polar radius? Who understood its equatorial circumference? Who recognized that Earth is not a perfect sphere but bulges slightly around the equator? And if such knowledge existed, why encode it into a monument? Why preserve it in stone at a scale that future generations could eventually decode? The conventional response remains the same. Supporters argue that these relationships are coincidental, emerging naturally from ancient measurement systems and a tendency for large structures to produce interesting numerical patterns. The machine actively tested that possibility. It searched for accidental explanations. It searched for innocent causes. Yet the pattern it continued to encounter appeared increasingly difficult to dismiss. The precision of the foundation exceeded practical requirements. The alignment to true north surpassed ceremonial necessity. Pi appeared repeatedly within the geometry. Phi emerged in multiple independent locations. And the dimensions of Earth seemed to echo through the monument when multiplied by a number connected to planetary rotation. Viewed individually, each observation could be debated. Each could be challenged. Each could potentially be explained away. But when examined together, they formed something larger than a collection of curiosities. They formed a pattern. A coherent signature. And when the machine evaluated them collectively rather than separately, it arrived at a conclusion it presented without drama, speculation, or certainty beyond the evidence itself. Importantly, it did not identify the builders. That distinction matters. It did not point to extraterrestrials. It did not claim a lost continent was responsible. It did not name a forgotten civilization and declare the mystery solved. Instead, it did something far more unsettling. It examined the conventional narrative, the pharaohs, the copper tools, the sledges, the 20-year construction period, the Bronze Age workforce, and judged that explanation incomplete. Not necessarily false. Not necessarily deceptive. Simply incomplete. Insufficient to fully account for everything present at Giza. The machine did not replace the accepted story. It removed certainty from it. It exposed gaps and then left those gaps empty. And in doing so, it forced a more difficult question. If the traditional explanation does not fully account for the evidence, what would? Because the anomalies are specific. Extraordinary precision. Mathematical relationships that appear far ahead of their supposed discovery. Massive engineering achievements, including 80-ton granite chambers and load distribution systems that have endured for over 4,000 years without catastrophic failure. Taken together, these observations place pressure on many of our assumptions about what was possible. And beyond the pyramid itself stands another puzzle. The Sphinx. Its weathering patterns have fueled decades of debate, with some researchers arguing they point to periods of heavy rainfall that occurred long before the dynastic era traditionally associated with the monument. Whether one accepts that interpretation or not, the question remains part of the broader discussion. Once the conventional explanation is set aside as incomplete, several possibilities emerge. Perhaps the ancient Egyptians possessed technologies or techniques that were later forgotten. Perhaps they inherited knowledge from an older culture that existed before the dynasties. Perhaps advanced understanding survived from a civilization that preceded recorded history and was largely lost after the end of the last ice age. Or perhaps there are possibilities we have not yet imagined. The machine did not choose among them. Nor could it. Its role was not to declare certainty where evidence remains incomplete. Its role was to identify where questions remain unanswered. What it ultimately offered was something simpler. Permission to acknowledge uncertainty. Permission to admit that some aspects of these monuments remain difficult to explain. Permission to recognize that the precision is real, the mathematics is real, and the questions are real. Whether those questions ultimately point toward forgotten technologies, lost traditions of knowledge, misunderstood construction methods, or something else entirely remains open for debate. And perhaps that is the most important conclusion of all. Not that we have solved the mystery, but that we may not understand it as completely as we once believed. So consider the evidence for yourself. Set aside assumptions for a moment. Look at the measurements, the alignments, the geometry, and the extraordinary precision. Then ask yourself, what explanation do you find most convincing? Forgotten Egyptian techniques? Knowledge inherited from an older culture? A civilization that predates recorded history? Or something else entirely? Whatever answer you choose, the conversation begins with the same place. The stone itself. Maybe the machine is wrong. Maybe every anomaly has an ordinary explanation waiting to be discovered. Maybe the precision, the mathematics, the alignments, and the countless mysteries hidden within the stone will someday fit neatly into a story we can all agree on. Or maybe they won't. Maybe the Great Pyramid is reminding us of something we have forgotten, that history is not a completed book. It is a puzzle with missing pieces, and every generation has the responsibility to look again at what it thinks it already understands. The truth is that no matter which explanation you believe, one fact remains unchanged. The monument is real. The measurements are real. The questions are real. And until those questions are fully answered, the mystery remains alive. So now I want to hear your opinion. What do you think the evidence is telling us? Which explanation makes the most sense to you? Let me know in the comments below. And if you found this investigation interesting, share this video with someone who loves ancient history, archaeology, engineering, or unsolved mysteries. The more people who examine the evidence, the closer we may come to understanding what really happened on the Giza Plateau thousands of years ago. Because sometimes a single question can change the way we see the past. And sometimes the greatest mysteries are the ones we thought were already solved. If you enjoyed this video, please like, subscribe, and share it with friends who love history, archaeology, ancient mysteries, and unexplained discoveries.